All right, welcome to the Explainer. Today, we're not just going to study toxicology, we're going to master it. We're going to break down a final exam level question step by step using a real world case to build the ultimate revision guide for how the body handles THC. So, here's our game plan for getting that top grade. We'll kick things off with our patient, Mark. Then, we'll systematically trace THC's entire journey through his body, where it goes, how the body tries to get rid of it, and finally, we'll tie all that amazing science back to the actual symptoms he was experiencing. First up, we've got to understand the scenario. All good toxicology starts with a real person, and our case today is a 3-year-old boy named Mark. This isn't just some abstract problem, it sets the stage for every single biological process we're about to dive into. So, Mark gets rushed to the ER, and he's showing some really scary symptoms. He's confused, his speech is slurred, he can't coordinate his movements. It's quickly confirmed that he accidentally ate some cannabis edibles. Now for us, two things are absolutely critical here. His age, just 3 years old, and the specific substance involved, the xenobiotic, THC. Okay, let's get a key term down. THC is a xenobiotic, which is just a fancy word for a substance that's foreign to the body. But here's the really important part. It's highly lipophilic. That means it's fat-soluble. And trust me, that one single chemical property is the key that unlocks everything about its journey through the body, how it moves, where it hides, and the damage it causes. Okay, now that we have the backstory, let's tackle the first part of this exam question. We are going to trace the entire journey of THC from the moment it was ingested to the moment it's excreted. This is the absolute core of toxicology, understanding what we call the ADME pathway. And here's the question. It's asking for a flowchart describing ADME. Now, that's an acronym for the 4 big stages: absorption, distribution, metabolism, and excretion. And look at that weighting, 30%. This is a huge chunk of the grade, so we are going to absolutely nail it. So, at a glance, here's the whole journey. It gets absorbed in the gut, distributed through the blood, metabolized by the liver, and then finally excreted. But the top marks are always in the details, so let's break down each of these stages one by one. So first up, absorption. This all kicks off in the small intestine. Now, because THC is so fat-soluble and doesn't have an electrical charge at the body's pH, it just slips right through the cell membranes of the gut lining. It's a process called passive diffusion. Think of it like rolling downhill. It doesn't need any energy, it just follows the concentration gradient from high to low. Simple as that. Okay, once it's absorbed, THC doesn't just spread everywhere. No, it takes a mandatory detour straight to the liver through something called the portal vein. This is the famous first pass effect. The liver acts like a bouncer at a club, a screening checkpoint, breaking down a huge chunk of the THC before it even gets a chance to enter the main bloodstream. This massively reduces the initial dose. And this, right here, this is a perfect example of why pediatric toxicology is its own special field. Mark is not just a little adult. He has way less body fat to sort of soak up and buffer the THC, which means more of the active drug is floating free in his blood. His detox enzymes are still developing, so they're slow. And to top it off, his faster blood flow delivers that poison to his brain with terrifying speed. Right, so after distribution, the body's main goal is just to get this stuff out. But there's a big problem. You can't get rid of a fat-soluble compound in water-based fluids like urine. So the body has a brilliant solution: biotransformation. It's a 2-step metabolic process designed specifically to turn that fat-loving THC into a water-soluble form that the kidneys can actually flush out. Okay, so some of the THC has survived that first pass filter in the liver and is now cruising around in the bloodstream. The next obvious question is, well, where does it go? Which parts of the body does it actually hit? And where does it get stored away? And wouldn't you know it, that is literally the next part of the exam question. We need to name the main target organ, pick out 2 storage tissues, and, this is key, justify our answers based on what we know about the molecule. So here's the bottom line. The primary target, the place where THC actually causes all the chaos, is the central nervous system, the brain. But because it loves fat so much, it also gets stored in other places, mainly adipose tissue, that's body fat, and the liver, which is the organ working overtime to process it. The justification here is actually pretty simple and elegant. It all comes down to the idea that like seeks like. THC is a fat-loving molecule, so naturally it's drawn to any environment that's rich in lipids. The brain has a high lipid content, and THC can waltz right across the blood-brain barrier. Adipose tissue is literally a fat storage depot, and the liver is getting a massive blood supply and is central to processing everything. It all makes perfect sense. All right, now we get to the real beast of the question. We've figured out where THC goes, but how exactly does the body perform that chemical magic trick to turn it into something it can get rid of? This is the amazing process of biotransformation. Okay, so this one's broken down into 3 parts. We've got to be methodical. First, we need to define first-pass metabolism again and name its 2 sites. Then we have to describe the 2 phases of detox in detail. And finally, we need to zoom right in on the specific job of a super important family of enzymes called cytochrome P450. First, that definition. First-pass metabolism is the pre-systemic clearance of a substance. In plain English, it's the body's first line of defense, breaking down a chunk of the xenobiotic before it can go system-wide. This happens in 2 main places. First, right in the wall of the gut, the GI mucosa, and then, much more significantly, in the liver. Biotransformation is this beautiful 2-step process. Think of it like a detox factory line. Phase I, which we call functionalization, uses enzymes like CYP450 to stick a little chemical handle onto the THC molecule. Then phase II, or conjugation, comes along, grabs that handle, and attaches a big, bulky, water-soluble tag. That tag is basically a big sign that says, trash, remove immediately. And this is what I think is so cool about phase II. It's not just one reaction. The body has this whole incredible toolkit of enzymes ready to go. It can use UGTs to stick on a glucuronidine molecule, or salts to add a sulfate group, or GSTs to attach glutathione. This metabolic flexibility is absolutely essential for dealing with the thousands of different foreign chemicals we might encounter. So if you remember one thing about phase I, it's this. Cytochrome P450 is the star of the show. It's the primary engine. Tucked away in the liver, this family of enzymes performs that critical first chemical reaction on THC, oxidation. It's the one that adds that all-important hydroxyl handle, which sets the stage for the entire phase II cleanup crew to come in and do their job. All right, we've gone through all the nitty-gritty science. Now for the payoff. Let's connect all the dots. How does all this complex toxicology perfectly explain Mark's specific symptoms back in that emergency room? And here is where it all comes together beautifully. Mark's slurred speech and confusion? That's a direct hit from the fat-soluble THC waltzing right across his blood-brain barrier. Why were his symptoms so severe and long-lasting? It was that perfect storm of pediatric factors. His low body fat meant less buffering, and his immature enzymes just couldn't clear the drug quickly. And the kicker? Something called enterohepatic recirculation, where the detox metabolites get excreted into the gut but are then reabsorbed, essentially giving the toxin a second or even third lap around the body. You know, Mark's case isn't just about THC. It's a perfect model, a masterclass for understanding how our bodies deal with pretty much any foreign chemical. And it really forces us to ask a much bigger question. Knowing these intricate pathways, this whole system of ADME, how does our own unique body, our age, our genetics, our health, shape how we respond to the countless other xenobiotics we all encounter every single day?